Can I go ahead and start? Yes, please. Oh, sorry. Good morning, everybody. I'm Jaime Rodriguez. I'm a Windows evangelist, and you're going to spend the next hour with me. And I'm going to talk to you about how to take your iOS skills and apply them to Windows Store application development. So first of all, thank you very much for coming. I know it's early in the morning after the party, so thank you very much for coming. Before I start, let me tell you, I've spent the last 12 months or so talking to iOS developers, in some cases helping companies move their iOS application. And I want to begin with this premise because what I found is that everybody finds building a Windows Store application very easy. They have all the knowledge. They already know the patterns. They already know all the technologies. All they have to do is learn a few new APIs and learn a few new tools, so get over a few little humps. And that's what I'm going to try to get. I only have an hour, so I can't teach you every single API, but I'm going to try to get you over those significant humps like the tools and the patterns that we use so you can very quickly map onto Windows Store application development. This is kind of the slides. I'm first going to talk about narrowing the choices. This is a common question that I get. And then I'm going to give you tips around the tools and the UI patterns. And then I'll give you a little bit of our story around store and submission because we have a really great story there. So hopefully, if you've been at Build for the last 3 days, you've seen some version or some flavor of this diagram. This is kind of how we think about Windows Store application development. And there's two interesting takeaways from this slide. The first one is choice. If you look at the top, there's a lot of programming choice, programming language choice, right? You can choose C++, you can use C#, you can do JavaScript. And the other thing that you can do is you have a presentation choice. You can use HTML, you can use DirectX, or you can use SAML. So everybody that I talk to from iOS tells me, hey, tell me what I need to do, right? I want to know how to pick the right technology for my job, and we're going to talk about it a little bit. But the second takeaway, which is the one that I want you to grasp from this slide right now, is the fact that all of this choice is built on top of one core API, the Windows runtime, right? So where WinRT API is what matters, and that's going to be really interesting for you, because if you're coming from iOS, here's kind of me fleshing out the frameworks or the components that are on the Windows runtime. As you can see, there's components that you should all be familiar with. There's controls, there's input, there's sensors, there's location. There's all these concepts that you're already familiar with, right? If I map these, which is the Windows runtime at version 8.0, onto what I get from iOS whenever I code my applications, you'll see that there's always something, there's an alternative there. You'll be using different names, you'll be using different classes, but the classes are all there. So it's going to be very easy for you to port your code. You're not redesigning, you're not re-architecting. All you're doing is kind of porting that business logic that you already have onto a Windows runtime environment. So that's one thing that hopefully you'll remember. There's one core, regardless of the presentation choice you make, which I'm going to talk about next, you will be coding to this one core. With regards to presentation choices, let's begin with HTML and JavaScript, because that's the one that iOS people misinterpret the most. Whenever I talk to anybody who comes from the iOS world about HTML and JavaScript development, they immediately say, no, we don't do that. And they're expecting, the reason they do that is because they're expecting that it's going to be a web view model with some sort of bridge like PhoneGap, Adobe Cordova, or something else, Sencha, that is just kind of bridging from web view onto native APIs. And that's absolutely not what we have when we talk about Windows Store application development using HTML and JavaScript. What we have is that you will be coding to HTML, CSS, JavaScript, all of the standards-based stuff, but those APIs will have full access to the native platform. So from within your JavaScript, you will be able to open a network file. You will be able to make a network call. You will be able to do anything you want, getting down to those WinRT APIs. The easiest example that I tell people is Skype. Anybody who knows what Skype does can tell you it's a very complex app. There's a lot of threading. There's a lot of media decoding. There's a lot of networking stuff. Think about what Skype does. And Skype is actually an HTML JavaScript app. They're calling onto WinRT APIs a lot, and they have some C++ business logic, but at the higher level, it's HTML and JavaScript. So definitely do not be afraid of HTML and JavaScript. If you think about the web view model, right, at least the way my experience is, I built a few of those apps in iOS, it runs slower inside the web view. The JavaScript runs slower inside the web view. We don't have that at all. Our JavaScript actually runs faster or just as fast inside our Windows Store application model as you get inside IE 11 or IE 10. Right? So our JavaScript is very fast. We don't give you memory limits like 10 megabyte memory limit or anything like that. We give you full access to the native APIs. Don't be afraid. If you have HTML and JavaScript skills, don't be afraid to go ahead and keep those and embrace them as you go down into our world. And then the one thing that we do give you that's extra is our Win.js library. This library is going to give you the native controls, that Windows familiarity, which I'm going to show you later in the day. It's going to give you those extra controls that you need that are specific to Windows that are not in the standards-based APIs. But the library is built on top of JavaScript. You'll be able to debug into it. You'll be able to tweak it. You'll be able to do whatever you want. So it's very, very powerful what you can do with HTML and JavaScript. Definitely not a WebView bridge type scenario. So that's what you're going to get from HTML and JavaScript. If you're interested in that, I highly recommend the session today at noon, reusing web skills in Windows Store application development. We have Ralph, who's actually on that screen in Skype, presenting about, he's a jQuery board member, and he'll give you the story about how him as an external, how he uses Windows Store, and how he thinks, or what he thinks about the power of the platform. So it's a really great session that we have today at noon. If you're running games or any other really graphic-intensive application, then for you, we will have DirectX. And DirectX is just our graphics API. It's very, very powerful. It's the equivalent to OpenGL. DirectX is more advanced, so you're going to have everything that you expect with regards to feature. You're going to be able to find if you're coming from the OpenGL to the DirectX world. As you see there on the screen, I actually put two screenshots. The first one is Chimpact. Now that you have your Surface Pro, go check out that app. It's a very fun app. Your kids are going to love it if you have kids. And it'll show you how beautiful you can create a DirectX application. And then on the bottom, I actually have a screenshot of Jelly Run, which is kind of one of the most recently released games built on top of Unity. And the reason I put that screenshot there is because most of you, if you're coming from iOS, you might be coding to a higher level framework already, like Unity or Cocos 2DX or something similar. And in our world, those frameworks are actually built on top of DirectX. So I work with some of those vendors, and we make sure that they have a really kind of a very seamless port, so you can bring your Unity code onto Windows Store application development, but it's built on top of DirectX, so you get the power of the platform. So if you're doing games or graphic-intensive apps, DirectX is where you're going to go. And you're coding to DirectX on C++ from the language standpoint. If you're interested in that, today at 2 p.m., we actually have a session dedicated to bringing OpenGL games to Windows Store. This is coming from Android or iOS, so they're a little bit more neutral, but it's just the same OpenGL API, so you can just bring them onto the Windows Store. And we have a session that helps you port all of that, because I'm not going to talk about it much more. And then the third model, which is the one I'm going to use today because it's the one that's closest to Cocoa, it's the one that iOS developers tend to immediately gravitate to whenever I talk to them, is our SAML version. And SAML is kind of a really nice, kind of in between those two choices that I gave you earlier, because SAML is going to give you object-oriented languages like C#. You can use C++ or Visual Basic. So it gives you an object-oriented language. It gives you, control model like what you get out of UIKit. So you'll have all the core controls. You have really nice implementations. And it also allows you to embrace the power of DirectX. So for example, here I chose the Nuke application because that's a really beautiful application. You see a lot of grid views. You see a lot of controls, navigation on the catalog, really a lot of kind of UIKit equivalent functionality. But then you also see when you get down to the reader, it's all DirectX. It's very fast. It's very efficient. And they're actually reusing a lot of code from other platforms, right? So at the graphics level, they have a kind of a language or a graphic neutral C++ API that they use to render their books everywhere. And they use the exact same APIs that they're using on iOS or Android, right? So that's kind of that's the model that we're going to embrace most for today. So that's it. There's three languages. There's three choices. You can't go wrong with either one if you kind of look at your scenario, right? The one that I highly emphasize is if you're doing graphics, definitely gravitate towards DirectX. With regards to HTML and SAML, you're going to get great functionality out of both. You're going to get great performance out of Dot. So there's not a lot of wrong decisions that you can make. Another example, that would surprise people is our mail application. If you think about the mail application that you all got on your Surface Pro, not the Outlook one, but the mail application that you got, that's also built on top of HTML. If you think about it, that's probably one of the most data-intensive apps we have on the store. And is using HTML, again, on top of a C++ layer that accesses WinRT, but it's HTML. So there's a lot of that. You can definitely do great stuff with HTML. Regardless of what you choose, you will get down to Visual Studio. So the next thing I'm going to do is just give you a couple tips on Visual Studio. And let me just do that. It's easier if I showed you there. So you've been here 3 days. I'm sure you've seen Visual Studio. But I'm going to walk you through just a few tips on the things that I see that, iOS developers always struggle with. So I'm just going to go here, say File, New Project, walk you through a couple of the features in the IDE. So I'm just going to create an empty project, a blank app, which is the equivalent of the empty template that you have. As you can see here, we have same templates or similar templates like you do in Xcode. I'll just select an empty one and walk you through a couple features on the IDE. And I'm going to focus on the code. We'll get into the UI a little bit later, so don't worry. I'm going to focus first on the code, kind of editor navigation features, and then we'll get to the UI in a minute. So you'll see here, if you see, again, you've seen Visual Studio for the last 3 days, but we have here our Solution Explorer, which is the equivalent of your Project Navigator. Right here, I have my Property Inspector at the bottom. Very similar functionality to what you have. And let's imagine that we're going to use, we're going to create a little random number generator later. So let's go ahead and write some code. So here you see, as I start typing, IntelliSense, let's just see that. IntelliSense kicks in and tries to correct all my typos and everything else. This is going to help you a lot with regards to your learning and discovery of the APIs, right? So here I'm just creating a random number. I'm not going to assign it to anything. We'll do that a little bit later. But this is the IDE. You're going to get it's a really great IDE. You're going to get a really great editor. You're going to get really great navigation. The interesting for me is that when I talk to iOS developers, the things that they get stuck on are very, very simple. For example, everybody tells me, Jaime, how do I see the help file? Right? We're used to in Xcode, we just kind of like tap out and then click something, and then we see the API right there. So if you want to do the help file here in the editor, just press F1 on any class, and you'll see the help viewer come up, and you'll get the help for that class. Right? So people actually don't discover that very easily. Now, one thing there, if you're going to use the help file, or if you like to read the help file a lot, our help by default come here, and if you look at help set help preference, we have the option to launch it in the browser, which automatically tries to connect to MSDN and download the latest version of the documentation there, so it gives you kind of a web page. Or if you want to get offline help, then you actually have to select right here the launch in help viewer, and you download the help files for offline viewing. So that's the one thing that you have to do with regards to the help, and it's very easy for you to now navigate through everything. We have a new feature in Visual Studio 2013 where, for example, right here, I can right-click here and actually see the help inline if I want to. So that feature will actually be nice. It's nice for you to just navigate through the APIs. Another thing that people ask a lot is hey, I want to go to the declaration or go to definition for a class. Right? So for example, here I do the exact same thing. I'm in random, I just select on the class, I press F12, and that's go to definition. Right? All of these features you can discover by just right-clicking. That's something that I see a lot. People come and say, hey, how do I do this? And I'm just like, right-click where you're at, and you'll have the menu right there. So here I pressed F12, I went to random, and I want to show you, we do navigate back. So there's a back button, just like you get in Xcode. So from there, I was in main page SAML.cs. I jumped onto the random definition. I see the next method, which is the one I'm using, and I wanted to confirm the parameters. And I can just click back, and this is going to send me back to the main page. Right? So you can navigate through the editor very, very quickly. These are ironically the things that people email me consistently with, oh, I don't know how to do this. Right? The next one that we get people a lot, or ask me a lot, is they're talking to me on the phone, and they said, hey, Jaime, how do I do this? And I tell them, oh, look for the stack panel class. And they're like, oh, I don't know how to find it. You can obviously search on the help file, but another thing that we have, which is very useful, is Object Browser. So you can see here, if I go View, we have an Object Browser feature. And from here, you can navigate through all of our APIs very quickly. You can just start expanding at the namespace level and just go look for the things that you're after. Or you can come here, and for example, if I was looking for stack panel, I can just type stack panel, and then it automatically filter, and it brings you exactly that documentation. And from here, you can read the documentation for the properties, you can see the APIs. So it's a very easy way for you to discover some of the APIs that we have very efficiently. Next thing I want to show you is a little bit of the idea of the debugger, just because that's another feature that's pretty cool, and people always, kind of want to learn a little bit more about it, because there's some features that you might not have seen in other IDEs. So what I'm going to do here is I'm just going to say, hey, use the simulator, so I can also show you the simulator while I'm debugging. And we haven't written a lot of code, so this application right now is not very interesting. We'll make it a little more interesting later. But I'm just going to launch it in the simulator. And you'll see here my simulator is coming up. And it's actually deploying onto the simulator. And notice that my simulator, you'll see in a minute that my simulator is actually remote desktop onto my machine. But here I hit the breakpoint, so you're going to have very similar functionality to what you get out of Xcode, right? I can right-click here and disable the exact same breakpoint. I have different options here for watching things. For example, here I have my locals variables, very much like I get out of Xcode. But then we have the ability to add, for example, this watch window. And in this watch window, I can just, for example, drag a variable. Or I can just type anything. I can type any expression, and I can just evaluate it there. And this will continue to evaluate as I go. So for example, right here, if I say R equals null, this will evaluate. And as I step through, for example, if I actually nulled it, if I go right here onto the immediate window where I can set commands, I can say R equals null and assign it. And you see that the watch window is automatically changing. So you actually have automatically updating of your watches as you go. You don't have to do PO and kind of enter everything as you go all the time. So very powerful debugger that we have. Some of the features, some of the windows that people always ask about are, hey, what are the other windows? The call stack you're familiar with, it just shows you a call stack. It's not different than what you're seeing. Breakpoint shows you all the breakpoints that you set. I disabled the breakpoint earlier, so you see there. There's nothing there, but as I add it back and forth, this is updating live and giving you that. Command window is something you can use to send commands within the IDE. So for example, earlier we were looking at stack panel in the object browser. I can come back here and just say from within the command window, I can just say help stack panel. And that's actually going to launch the help, and it's going to bring the stack panel. So if I want to navigate quickly with the keyboard from within the command window, I can do things like copy files, build. You get familiar with the commands, and you'll be very effective at navigating through that. And then the immediate window is very much like a watch window, but here I can type a little bit more, do expressions, call methods, do stuff that evaluates. And of course, we have an output window where you have your standard debug output, and you have everything that you write to the console and everything else. So let's go ahead and let it continue so we can get to the simulator. Oops. Oh, I set it to null, so now I have a breakpoint. Let's do it again. Sorry, I set the variable to null. I'm improvising as I go, in case you haven't noticed. So now it's going to come up in the simulator. Now, this app is very boring, but I want to show you a couple interesting features in the simulator. The first one is our simulator is actually remote desktop onto the machine. So here, for example, I can come back here and just type my Windows keyboard, and I get my start menu. So this is literally running a remote desktop onto my machine. I can access any application here. So if I need to collaborate, maybe share or do a contract with other applications, I can interact with it in the simulator, and I still have a debugger attached. So that's kind of nice. The other things that I can do with the simulator are, for example, you see here I'm using mouse, but I can simulate touch. So if I want to pan around, I can simulate touch right here. Single touch, I can even do multi-touch. So for example, here, if I want to pan around with multi-touch, you see here it's acting as if I had two fingers, right? And I can do rotation, for example, right here. If I can go back, I can do rotation so that I can test my application as if I had an accelerometer on my device, and you see what it's going to look like as you rotate to portrait and landscape and everything else. If I was running an application here, all the right events that said, hey, your rotation has changed, your view has changed, the new sizes are available, all of those events will be fired, and those are truly simulated, and you're getting everything in there. We can also do, for example, location, so we can simulate location here. Let me just flip it around. If I wanted, for example, the weather app, and I want to simulate my location here, I just type the latitude and longitude, and this will simulate, and the APIs for location will return these from within my application, and I'll be testing against it. You can get screenshots, and then you can simulate network, which is pretty cool. If you want to simulate, meter networks or roaming or any of those things, if you're running a network, an application that has a lot to do with network, you can simulate all of that from within the simulator. And the last thing, which is very, very important, and I want to highlight it, is you can actually simulate different screen sizes, and this is very important to Windows. Windows is, you have be coding to one API, so there's only one WinRT API. We're not fragmented there, but we do have a lot of different form factors. Right? We go anywhere from that little tablet to those really big screens. So, and you're not going to have every possible piece of hardware. So what you do here is you come on the simulator and you can simulate any kind of resolution. So for example, right now, it's acting as if I was running on a 23-inch screen with 1920 by 1080 resolution. I can go back and say, hey, what's this going to look like when I'm running a 10.6-inch with 4:3 form factor? And you can see the changes, and you can see how your layout and everything else is going to react from within your app. So that's the power of the simulator. That's what you're going to get out of Visual Studio. That's at the highest level, really brief overview of Visual Studio. Those are the few things that people struggle. Actually, there's one more that people struggle with, and this one's actually very interesting. Everybody calls and says, look, the ones say, I love Visual Studio, it's got a lot of functionality, I'm learning it, it's great. You're not going to struggle to get around it. The one thing that people always want to customize is the key bindings, right? If you're coding in Xcode all the time, you're used to doing like Control-B to build or F6 for, stepping and stuff like that, and the bindings are different. What you do here, let me show you the step again, because this one's the one that you want to remember, is you go here and just say Tools, Customize, and then click on the keyboard, and from here you can customize all your key bindings. So for example, if you want to do build solution, right, you can customize your bindings here and see like the ones that we come back with. You'll see like, for example, I have it mapped to Control-B because I go back and forth on Xcode a lot. Control-Shift-V is what they use for most of the time in Visual Studio. Now, the other thing that you can do here is a lot of people ask, well, what about Emacs emulation or BI emulation, right? Because they're used to those editors. And what you do here is, in the more advanced versions, we have two versions of Visual Studio. Express, which is the free version, and then we have, real SKUs like Pro, Ultimate, and all those. If you have something that is not Express, we have the ability to add extensions. And in one of the extensions here are keyboard mapping schemes. So here, where I don't have any of the external ones because I'm using the free tools, you can actually add a keyboard mapping for Emacs or BI. You can just go online to our gallery, to the Visual Studio gallery, do a search for Emacs emulation Visual Studio or VI emulation Visual Studio, and you'll be able to get those mappings so that you can code it. Again, these are not on the free version, but if you're just getting started, what you should do is we have 90-day evals of Visual Studio on the higher level SKUs. So for anybody who's getting started, the easy thing to do is download the 90-day eval, the 90-day eval, and then bring in your key bindings so that you're familiar with, you're more effective as you start coding, and then build your application, and then at the end you can decide, oh, I'm going to buy it, or no, I'm not going to buy it, I'll go back to the Express, but at least you'll be able to use the key bindings that you like, the key mappings that you have, and be more effective while you're just getting started, because that's one of those things where if you're slow when you're getting started, it's going to discourage you a little bit. So that's kind of what you get out of Visual Studio. Again, it's a high-level overview. I didn't show you any of the really powerful features. I focused on showing you features that iOS people always struggle with when they talk to me over the phone and tell me, hey, this is where we're at. So moving back to here, let's move to UI patterns so we can start diving into more meaty stuff than just walking you over the tools. Before I get into patterns, I do want to introduce you to SAML. Okay, that didn't refresh here. So I do want to introduce you to SAML. This is the serialization language that we use for creating UI. If you ever open a SIB, it's not very different from a SIB. It's just something where we serialize objects onto an XML format so that we make them much more toolable. That said, when I compare the serialization that I see from SIB to what I'm seeing out of SAML, SAML is much more powerful, much more expressive. So for example, this simple code snippet right here, we have a page with a grid inside of it and with a button inside that grid. And if you're looking at some of the features that we're showing you, first of all, we have the page, which is kind of our container. And then we start displaying like a visual hierarchy where you see the grid is a subview on the page, right? And then the button is a subview on the grid. So just from the hierarchy, you get a visual hierarchy there that we're implying, and that's how we're creating all the subviews as we go, right? The next thing that you see is styling. I'm not going to give you a big demo on styling, but if you're familiar with CSS, that's the kind of styling that you get when you're doing SAML. It's just that you're representing an HTML. So you get cascading style sheets, you can inherit, you can do based on. You have a lot of power with our customization, much more powerful and much more toolable than, for example, UI appearance. right? So we have more power and we have more, a little bit more toolability. I'm not showing you all of this in the tools, but we have Expression Blend, which is a tool where you can go in and customize all these styles and create really compelling applications. The next thing that you're seeing from just this code snippet is outlets. So for example, right there on my SAML, if I just type button x name equals, that's actually creating an outlet, right? So I don't have to do the drag, drop, and all that. I can just go in there and do x name, and I'll automatically get an outlet. I also have bindings, so we're going to show you data binding later on. It's very powerful. It's a feature that we use a lot in SAML. And then obviously you're seeing the layout constraints that you can actually get. And our layout is much more, Xcode layout as in the later builds is getting much more interesting. But the toolability is hard. On our world, we give you a lot of control with toolability so you can control the layouts without having to do constraints. We're very explicit. And all of that can be represented in SAML. So I wanted to give you that just because as I get to UI patterns, I'm going to use some of the SAML. To be honest, if you're going to write an iOS application, last year, for example, we ran a lot of trainings with Big Net Ranch, training iOS developers on Windows. And it's funny because SAML is one of those really big parts of the framework that you're going to spend a lot of time. Like we have a 5-day training, or they have a 5-day training, and we usually spend about a day and a half of 5 days just teaching people on SAML, probably closer to 2 days teaching people on SAML. So this is the one area where you're going to have to do a little bit of learning. And we have a training coming up. There's an online, it's going to be online, it's free. You just log in and watch it that day. And we have a training from 9 to 5 on July 12th. So remember that link, or go back and look at the presentation and try to log in. There's the agenda for the training that we're having. If you don't know Laurent Bugnon, he's the kind of a creator of this open source framework called MVVM Lite. And he's a very, very intense SAML expert. And he and I are going to go very deep into SAML and show you how to be very productive, how to get a lot of the internals of SAML so you can get the most out of it. So definitely join us if you can. It'll be recorded and it'll be available for offline. So if you're in a different time zone and you're thinking, oh, 9 a.m., that's late, you'll be able to watch it offline afterwards. So. Moving on to patterns, I cannot talk about patterns without obviously talking about MVC. And this is my simplified version of MVC. So this is kind of how I think about it. I think we have, model view controller. We use outlets to communicate between controller and the view. And we actually use target action pairs and delegation to communicate back and forth between the view and the controller. So how does this map onto a SAML world? What are you going to get? And the nice thing about it is that out of the box, you're getting exactly the same functionality, and the IDE is kind of enforcing that structure. We don't enforce it as much as forcing you to name controllers, but if you see what you're doing with just dragging and dropping, you'll see in a minute that we're actually creating a very similar model to the model view controller. So let me walk you through an example of that. So we're back here. In our little application that we created earlier with the simulator. And you'll see here, now we get into the editor and to the UI editor. So here's our UI editor. Let me zoom out a little bit, or quite a bit, so you can see this. I'll go as little as that. You can see here, this is our editor. So this is what used to be Interface Builder, now officially just part of Xcode. And you'll see here, I have the exact same thing. Now, I actually have it such that I have my editor on top, and you can see the SAML right here at the bottom. And as I select things on the SAML editor on top, it's actually jumping around the SAML, showing you what I'm typing. What you see is with SAML, a lot of us that are experienced, we code a lot of the SAML by hand. I have the editor there, and I can drag and drop. I'm going to use drag and drop today. But once you're effective, it's very much like HTML. If you're an HTML developer, most of the time you start typing things by hand because you're more effective than just dragging and dropping stuff. We do the same. We're not afraid of editing by hand. It's XML. It's very readable. And our tools with regards to source control for merging and everything are pretty good. I know a lot of people that, they're like, oh, we never touch the sieve because every time we do, some things break, things break with regards to source control and merging and everything else. On our world, we tend to do that a lot. But if you like to do drag and drop, that will work too. So here we're going to do a little random number generator. So I'm just going to go here, and I'll drag a text block here. And I'm going to make it big so you guys can see it. And I'm going to add a button. So I'll just add a button right here. And I'm, again, making everything big. So let's go ahead and customize the look and feel here so you can read it. So for the button, let's add a little bit of a background, or we'll add the foreground color, and let's just add a little background so we can see it better. Right, and then let's make the text much bigger. So I can come back here, and I'm not going to change the text in there. I'm just going to change the font size. So that's a little bit easier for you to see. And then I'll do the same for the text box right here. I can change the foreground so it's a little bit more readable. And then the big deal is changing the font. And you can come here and customize anything, transform it, move it around, do layout, do everything that you're going to get. But this is a very basic view, and here's where the things get interesting. Because right now, I've done the drag and drop, so this is where things get interesting. This is where I have to create the outlets. I have to do the target action pair stuff. So if I want to make an outlet for these text blocks, I already told you, all I have to do is right here from within the editor, I just name it. So let's just call it random text block, and that right there created an outlet. You see here the SAML changed. It now has an X name. If I want to change the name or anything like that, I can come here and edit it by hand. And now I need a target action pair. So here I can just go to the button, and then, for example, I can just double click it, and it automatically create an event handler for me, right, which is the equivalent of an action pair. Or if I want to have more control over the name, I can come back here and, for example, go into the events list right here, see the list of all the events, and I can give it a different name. So, for example, here, let's just call it onClick. And again, if I press enter, it takes me back and forth to the code. And for example, here on the onClick, I'm just going to take that code that we wrote earlier. It's our little random generator. And I'm just going to put it there. And I'm going to say, remember we created the outlet. It automatically synthesizes for me and everything else. So I just had to name it there. I have my IntelliSense here, so I can just say random text block text equals random next, and this is assigning it. And for example, here I showed you earlier F12. So if I'm right here and I press F12 on that variable, on that outlet that's generated, and I said, hey, where was this defined? It takes me back onto the SAML. Right, so I can go back and forth very quickly with regards to my code. So that's what you're going to get. If you're looking at the structure, I did all that typing. The random number is not very interesting, but I did all that typing to show you the structure. So let's look at the structure, right? You have a SIB. Here, you have SAML. It doesn't look any different, right? You have a controller. Here, we call it code behind, right? So you have this class right here, which is my code behind, and my outlets are here, my target action pairs are here. We're using events, so you see that I did the button click event. That's an event. We don't use delegation as much from a pattern standpoint, but it's not that different, right? An event is nothing but somebody exposing a contract, very much like a delegate or like a protocol is when you're implementing a delegate. So it's the exact same functionality that you're getting, and there's a marriage between those classes. Now this is, if you think about it, this is a little bit more tightly coupled because right here, they're both on the same class. So for example, right here, main page here is married to that SAML, right? The C# compiler is doing some magic that it connects those two together into a single class. So you could argue, oh, well, you just created a tightly coupled view with your controller. Now, there's very easy ways to get around it. You can subclass these. You can just override the initialize and swap a different view. So there's many different ways for you to get around it. And then in a few minutes, I'm going to show you model view model, which is the pattern that we use a lot more. And you'll see how that's much more, that's totally loosely coupled. That is totally much more decoupled than anything you're going to get, even out of model view controller. So that's it. Let's just run this application to make sure I didn't do anything major mistakes, but running it is not going to be very interesting. So you're right there, click on the button, and I'm just getting random numbers, so nothing there. Very quickly, model view controller. That's what you get out of the box. So you're going to be there and be like, hey, this feels very familiar. I have the exact same separation. I have the exact same structure. And as you saw, you have really great support from within the tool. Now, we use a different pattern a lot more in the SAML world. So let me go back here and show you a slightly different pattern. It's actually not very different at all, but we have a different name, and we actually use slightly different technology, just a little bit more. So imagine the exact same model view controller diagram. I left all the iOS stuff there. Now we have this thing called a model view model. And what that means is you're still going to have outlets, and you're still going to use Xname for that, but you're not going to use them. Like the reality is with a model view model, we never use outlets. You have the ability to create one if you want it, but we hardly ever use them. Now the interesting thing is we have this thing called commands, which is a little bit more abstracted target action pair, right? So it's going to be a nicer way for you to abstract target actions. And then you see that there where it had data bind or where it had data sources, I'm going to replace that with bindings. So here what I'm going to do with a model view model, as the name implies, what I'm going to do is I'm going to have my view be completely driven out of this thing called a view model, which is data driving the view. And we're going to use data binding for a lot of that. So let me show you real quick. It's easier to explain on code than it is to go back. So I'm going to take this exact same thing. I'm going to add a new project so we can go and keep this clean. Right here in my solution, I can just say add new and add a whole new project. So this is kind of the equivalent of a workspace where I have multiple projects inside Xcode. It's just the equivalent of a workspace. So I'll just go back here, leave app 1. We don't really care for the name. And that just added a new project. And I can come back here and just to be lazy, and to show you how we tend to copy around SAML a lot more, I'm just going to go here and copy the SAML. So we have the exact same UI that we did on the other one. And while I'm here, I'm actually going to set my new as my startup project so that I don't cheat and show you the old one. So I'm going to go here to the SAML. And I'm going to, this time, I'm not going to load the designer as much. I'm just going to focus on the SAML. And we're just going to remove stuff. So we have the exact same UI. Ooh, I actually brought in the grid. So let's just remove the grid. Oops, hang on, did I? Yeah, so I'm removing too much. So I'm just bringing down the text block and the grid. And what I'm going to do here is I'm just going to remove the two things that we added. The first thing that we added was we added this target action pair event handler. So I'm going to remove that from the button because we're not going to use that mechanism anymore. And the next thing that I'm going to do is just remove right here from the text block, I'm going to remove the outlets. So that was the XName thing. We remove it there. We have the exact same view, but this view is right now not connected to anything. Right? And again, I told you we were going to drive it out of view model. So what I'm going to do here is I'm going to add 2 classes. So you don't see me type them. I'm going to walk through everything that I did in those classes, but it's easier if I just show you the code without me having to type it. It's a little bit faster, and we need the time. So I have these 2 classes right here. The first one is a relay command. Remember I told you we use commands to communicate inside of view model. So let's go here. By the way, relay command is a class that comes with every template. If I had chosen any template like a grid template or anything else, Visual Studio would have automatically added this class. The reason it is not in this one is because we use the empty project. Right? So I'm bringing you the relay command. I want to show you what it is. And you see here, relay command, it just implements an interface. Interface is the term we use for protocols. So think about just defining a protocol here. And I can just go and, for example, pick definition inline right here. I told you earlier we have a pick definition. And you see the methods. It only has 2 methods. One of them is can execute, and the other one is execute. What a command does is the UI, for example, a button, which is what we're going to use here, is going to call can execute and say, can you execute? And if you return false, then the button will automatically disable itself. Right? And then there's also an event handler so that when can execute change, the UI is going to be notified and the button will enable itself again. Right? So this is kind of nice because you don't have to write the business logic to enable and disable. You have this command which abstracts that. And then if the button is enabled and somebody clicks on it, then it's going to call execute. So all you're going to do is implement this protocol. You say, hey, can execute, and you'll return the right value and execute, and you'll have the right implementation there. And that's what relay command does. Relay command just says, look, I'm an implementation, so I'm actually an instance of a class that you can instantiate because you cannot instantiate the interface or the protocol. And it just tells you, hey, pass me the thing that you want to call back, and we'll do it. So that's what command does. Now, the other thing that I did is I have this other class called random number view model. And you'll see here it's got 2 properties. The first one's called number, and it's just a string with the number. I could have done an int, but let's just keep it simple and go with a string. And then the other one, it has this click command. So it has data, right? And you see here that it's implemented whenever I set the number, because this is a kind of a getter and a setter. You can see that whenever the number changes, it actually fires change notification. It's implementing this interface right here called iNotify property change. So this is nothing but making an observable object. and the UI is going to be able to observe onto it, and it's going to be notified. So I have those two properties, name and click command. So why don't we go back to the UI and just connect those two, right? So I'm coming back here, and I'm going to say, on the text box, I'm going to say, look, your text is coming from a binding to a property named number, right? And then on the button, I'm going to say your command is coming from a binding called click command. So I went to my view and I just told it, hey, here's what's going to drive you, right? And all I did is created bindings. I didn't write a whole lot of code. I have my view model over there. That's where the code is. And the one thing right now is my view and my view model are not connected. So what I'm going to go here is I go on the code behind, and I'm just going to say, look, my data source equals new sample random view model, right? And right there I have my data source and I'm okay. So that's it. I just connected the view onto that view model, and now, assuming I set it up to run, then I can just come back here and just run the exact same thing. Oops. Property text is multiple times, so when I copied my SAML, I didn't delete the text. Let's go back here real quick. And you can see here, actually that's nice for you to see, we do compile the SAML so we can kind of validate it right here. So let's go here. I got a text equals binding, and somewhere over here, I'm sure I have another text property. And you can see I can edit my SAML, make it a little bit leaner for you to read. I could be deleting some of these things. So you see text equals text block there. So let's just delete it. And now I can run. So now I have the exact same application, but I'm using a totally different pattern. And if I click on the button, I get random number generators again. Right, now let's look at the view, right? Because earlier when we did a model view controller, we kind of were a little tightly coupled. Now if I go back here, look at my view. The view has nothing. All it has is that one line where I say the data source, right? My view has those bindings in there, but this is it. Now I have true separations between that view model. In fact, I have so much separation, I can do something like this. I can come back here, stop the debugger, and I have a project open here for phone. And I can go into this phone. It has a view, and the view has the exact same binding. So I can say, hey, add those two classes that I just created. I'm just going to say add existing item. And in fact, I'm not even going to add the classes. I'm just going to select them here. And I'm going to link them so that I don't even have to move them. They're over there in that other folder so that my source control stays pretty tight. I'm just going to say add them as links. And I just brought them into this project, and now I can use them. I can go back into this main view right here and do the exact same thing that we did earlier. So I can just say this.data context equals new, and we call it sample.random number view model, right? And these are totally different view. It's totally different SAML. Actually, the SAML looks the same because we still use button and text block and everything else, but it's definitely a phone project, right? So now I can just say, hey, run this on the emulator. And I just brought my view model onto phone. And I can reuse that whole view model here, click it, and I get a random number generator. If I wanted to use this in Xamarin, I can use it in Android or iOS, right? Xamarin uses C#. With MVVM cross, I get the data binding functionality, and I could have taken that view model and reused it on my iOS or my Android app. So that's the pattern that we use. That's model view model. Obviously today, when I show you the infrastructure, adding a command and adding the property change notifications, a little bit more infrastructure at the data level, but you have a nicer abstraction. The reason we use model view model a lot, when I started on it, it was because of unit testing. We can do a lot of really great stuff with regards to unit testing when everything's driven out of that model, right? So I just need to test the view model and be okay. So that's kind of what the pattern. You can use model view controller, model view model. We don't really care. We have great support for both in the tools, so you'll be okay regardless of which one you want to use. So that's kind of the two patterns that I wanted to walk you through. With regards to controls and the rest of the UI stuff, all the core controls that you expect, you're actually going to get. We have everything comparable to what you get out of UIKit. And in fact, we have a little bit more controls. And if you're porting your app, I do want to show you this because this is interesting to me. A lot of people port their apps, and when they port their apps, you have to worry about your users. They're running on Windows, so they're expecting what we call the Windows personality. And there's controls that you're not familiar with that have that personality. So for example, here, if I show you something like the News app, right? Right here you're seeing this is a hub control. We have kind of a hero shot always in the beginning of the hub, and then you have a lot of content that you scroll through. And then you're seeing here some of the Windows controls. So for example, right here, this is our grid view, which is the equivalent of UI table view. And there's a lot of things that we do that are very specific to the platform. For example, I just drag down, and that's how we do selection, right? And I did it using touch. I can also, for example, use it do it using mouse, and everything, all the gestures and everything is handled automatically. Same for keyboard. If I press escape right here, everything gets unselected. So these are the native controls that are going to give you that Windows personality. You got to become familiar with them. Hub is one I just showed you. Grid view is one I just showed you. Another one that's really interesting for you is navigation bar and app bar. Right? So here we have a concept of a nav bar where you can use to get around an application very quickly. And then on the bottom, we have our app bar, which is what we use for commanding. Right? So these are very similar. If you think about all the controllers that we have in iOS, like tab bar controller, navigation controller, etc., these are the implementations of those, except for in our world, they're controls. And you're just going to be using them for your app. So that's some of the ones we have. We also have, for example, semantic zoom, which is another control that you can use to kind of like zoom out of a view, give them a condensed version, and then have them jump around with regards to their UI. So when you bring your app, all I'm asking you for is make sure you go back, you look at the controls, and you leverage the controls that will give you that Windows personality, because that's what your users are expecting. Next thing real quick, the other thing that's different from iOS is that in WinRT, all of our APIs are asynchronous by design. Anything that can take 50 milliseconds or less, or 50 milliseconds or more, is actually going to be asynchronous. And a lot of people get scared of that whenever I tell them, because they think about, oh, completion handlers and all kinds of messy code. Let me show you how easy do we make it, because the SDKs make it really easy for you to code asynchronous. So I can go back here, and I'm just going to show you some code that I pre-coded earlier. So here's kind of a little quick async demo. And I did two things. I just went back and got some code. All I did was say, hey, let's go ahead and make an HTTP request onto Bing, and then just get the page, right? So I'm just going to do get, which is a get request here onto Bing, and then I'm going to read it. And you see that asynchronous right here, I have kind of a get async, and then you would have, if you were coding iOS, you have a completion handler right here, which is our continue with. And I'm using lambdas to simplify the text. But you see here that I kind of have two nested asynchronous operations, and that's a little bit messy for people to write and read. With two is okay, but once I have 2 or 3 or 4 nested asynchronous operations, it gets a little bit messier. So the way we do it in C# is very, very easy. The compiler has these extra keywords. Check out this functionality right here. See right here we have the nested asynchronous. On our world, the compiler has this async keyword that you see right here. So I can declare async methods, and then whenever I'm going to make whenever I make an asynchronous operation that I kind of want to wait for, or that I kind of want to have my code be sequential for, I just call this keyword called await. And for example, right here, I'm just saying, hey, bar result equals await. Now this is truly asynchronous. The code to you looks like it's sequential. It's looking like, oh, isn't that going to block right there and wait for it? No, it's not waiting at all. The compiler is actually doing some magic underneath to make sure that they call the asynchronous operation, then they return to the caller, and then when the asynchronous operation completes, they call back onto this thread and continue executing. So for you, you're looking at this code, and it looks very easy to read. It's sequential. Now, let me show you what the compiler generated for us. So this code right here, it's asynchronous, and you'll see it right here. The compiler generated something that looks like this. Here's our download file using async keyword method. And you see here that it kind of creates a state machine. Behind the scenes, the compiler created this state machine. You'll never have to see this code, and you never want to debug this code, right? But we have good async debugging support anyway. But what you see here is the compiler created this state machine that says, hey, he's going to do all these asynchronous operations, and we're going to handle all of it. And then it generated this extra code right here, and you can see the code right here. This is what the state machine looks like. So it has the states. It's creating a waiter for like, oh, go ahead and get the request and get the HTTP response message. And then when you're going to read it, go ahead and create another waiter and get the string that you want to read. And it's doing the state machine for you, but you don't have to worry about it, right? For you, the code that you care about is here. It's very easy to read. It's sequential. All you have to do is make sure you understand that it's actually making asynchronous call and not create a dependency on a result that hasn't arrived yet. So that's very, very easy for you to read. It's very easy for you to go sequential. So that's the other thing that you'll see that's different. Last, I want to talk to you about the store. And I'm not going to talk about, the opportunity and all the really great APIs. But if you haven't checked it out, Ted Dworkin and Ari Cohen had some really great sessions on the store. Our flexibility on business is very, very good, much better than what you get out of Apple, right? We have trials, we have auto updates, we have a lot of features that they don't yet have. But I want to talk to you about the APIs and what a store submission kind of looks like, right? And I see that it's going to be kind of a 5-step process. You're going to register to the store. You're going to run a tool called WAC, which I'll show you in a minute. And then you're going to review your certification criteria or the guidelines, and then sign your app and upload to the store. Registering to the store is not interesting because, you just go to a website. It's no different than when you get out of Apple, right? You go to a website. So I skipped that step here. But WAC is really interesting. WAC is a tool that we give you. When you install Visual Studio SDK, we give you this tool called WAC. And what it's going to do is actually going to run tests against your app before you submit it to the store, right? Because if you've ever done it, like I've been in it before, where like I submit something to the Apple Store, I wait 4 days, and then they fail me because I didn't meet some basic thing or I made some mistake. Here with WAC, we run through all of the tests, as many tests as we can that we can validate for your technical compliance before you even submit. This is going to save you time. You don't have to submit and then wait a day to find out that you made a mistake or that you're not meeting the performance bar. So we give you a rich set of tests that you're seeing here, right? And you run through them. And this is doing for anywhere from code validation. It's actually looking at your static analysis. It's doing a static analysis on your code to make sure you're not using APIs that are not allowed. It's actually looking at your assets. For example, these manifests, which I ran late last night, failed because I had not overwritten the assets. I just left the default assets, and WAC automatically tells me, hey, you can't do that. That's going to be ugly if your app goes in there to the store with the default assets. So that's where I failed. So it's done some really great validation. And again, you're doing this before you submit, so you don't have to waste time, right? Once you submit, or before you submit, the next thing that you do once you're passing WAC is go back and check out our certification requirements. This is what Apple calls them the guidelines. And what we do here is we try to be very, very transparent. Our guidelines are posted publicly, so you don't have to be a registered developer to go read them. You can see everything that we want you to comply to. And then we have this extra page. Remember that URL right there, aka.ms/storefix. And that page is very useful for you to plan and troubleshoot. You can go in there and find the most common reasons why people fail certification, and you can actually plan for them and make sure you skip that. You don't fall into those traps because you have ahead of time the documentation that tells you what you need to do. So we make it very easy. We try to be very, very transparent with our certification, right? We don't have any holdbacks. If you want to write a specific kind of app, we take all kinds of apps as long as they meet the criteria, and that just means don't do something illegal, don't show content that's not appropriate and stuff like that. So we try to be very, very transparent. The next thing that you have to do, if you're familiar with doing an app, is just signing your app. And for that, within Visual Studio, we give you this UI that just says, hey, I want to sign my app now. It's a button right there in the UI. You call associating your app within the store. You click, yeah, go ahead and associate it. They make a web service call. They download the one certificate that you're going to need for your application, and they add it to your project, and you're done. There's no provisioning profile, there's no certificates, there's no, none of that environment stuff, right? When I write iOS apps and people add like a phone to our team, and they're like, oh, can you please add this phone? And I'm like, yeah, but it's going to take me 15 minutes to go create all the right profiles and go do everything else. We do the same for in-app purchase, right? On our side, with in-app purchase, we give you one little XML file that you use for testing your in-app purchase. And with that XML file, you can change your offering. You don't have to go register in the portal or anything like that. You just test your offerings, and then you automatically test everything that you need and do it on your own without having to go and do a lot of back and forth with the portal. So we try to be very, very efficient at doing all those things. It's interesting. There's a lot I didn't cover. If you didn't hear me talk about contracts, you didn't hear me talk about geolocation, any of those things. And the reason I didn't cover, there's two things. I didn't have time, And the second is because those are really straightforward. People that started, they're like, oh yeah, let me go look at the geolocation API. They see the properties and they're like, yeah, this looks exactly the same. iOS people are not struggling with the APIs. They struggle a little bit with the patterns. They struggle a little bit with the tools, just getting over the little hump, and that's it. The rest of it, when it comes down to the APIs, you'll be familiar with. Now, of course, there's some features that you haven't seen, like share and contracts and tiles and all this stuff. And for that, what I want to do is, on July 17th, again, we will have an all-day online free training, so you can just log in from your computer, watch it online or your own time. We'll have it available for on-demand. And this one's going to be presented with Eric Jeffers and Sean McCune for Beginner Ranch. Those guys started like a year ago, and they're iOS developers by training, during the day. They're some of the best iOS trainers in the world. And they started creating their Windows content and their Windows training. They have a 5-day training now, and we're not going to give you everything from that training, but we're going to give you a very good all day where we dive into the difference between, for example, C# and Objective-C. We dive into all the features like contracts and tiles and all the things that you're not familiar, the APIs that you just need to be aware of. Those APIs are going to be easy and straightforward for you to use. But you do want to get somebody to give you a little bit of tour and maybe talk about it again in the context of Xcode, Objective-C, and iOS. So join us that day if you can. And that's it. I began with this premise that I told you that you already know how to build Windows Store applications. You've been building applications for iOS or Android, and it's no different than that. Your architecture will carry. If you have cloud services, they will carry. So feel free to just get started as soon as you can. All the tools and everything to get started is free. You got it at the conference too. So thank you very much for coming. And I do have 5 minutes for question 4, so I'm one over the time that I allotted. So if anybody has any question, even if it's something I didn't cover, because I know I gave you basics, feel free to shoot me a question now, and I'm happy to tackle it. None? Go ahead.
Just a real brief overview of doing the applications for the Windows Phone. I know that wasn't the part of your conversation, but
Yep.
A lot of us iOS people are coming from phone apps, going to phone apps. Do you want to give us the bullet on that?
Yeah, so actually I show SAML and C#. That's the exact same model that we have on Windows Phone. You saw me bring that view model. If I open up that SAML that I show you on the phone, it's no different. It's the exact same model, the exact same tool. If you look at the SAML here, here I have my phone and I have them side by side. But if you look at here, oops, sorry. If you look at the SAML here, it's no different. So here I have my phone, my SAML side by side. It's just a text block and a button. So everything I told you about SAML is the exact same SAML. Everything I show you about view model is the exact same. Asynchronous is the same. Phone is actually built on top of WinRT. So when I started, I said, look, there's one core right here, the WinRT APIs. That core is right there on Windows Phone 8, right? So it's literally the same.
I was in another talk about writing apps that run on the phone and the tablet.
Yep.
There's lots of little differences.
So WinRT is, so it's the same WinRT. Phone does have a legacy because, I think if I can reword the comment, there's definitely some differences, right? Like for example, the UI, phone, it's the same SAML, but they have different controls. Phone has like a pivot control. They don't have hub and app bar, or actually they do have app bar, but they don't have nav bar. So there's a few differences in the controls and stuff like that. But the principles that I talked to you, like the patterns and the controls and the SAML and all that, the asynchronous, all of that is available on phone. So they're running in the same core. And we're going to get it closer together. I know at Bill we didn't talk much about phone and what's coming. We're just getting them closer together as fast as we can. Go ahead. Yep. So the question is, do we have the same binary and upload to one store? And the answer there is unfortunately not. That's something that phone started earlier, and we've kind of been playing this. They haven't yet converged. That's something we want to do in the future. But right now we have 2 different stores, and we have 2 different binaries. You can share. We have something called portable class libraries. So if I create a library, like for example, my view model, normally I would have refactored that and put it in a library that I can share. And if you create a portable class library, it's kind of a, it's like, think about it as a little framework or a library as you created. and that one can be shared. It's just like sharing a lib across 2 different projects, right? And that can be shared, but in the end, the package is different. On Windows, we have this thing called an Apex. On phone, we have this thing called a SAP. They're very similar. Like, we actually debated giving them the same extension, but there's a few subtle differences there with regards to the manifest, etc. So we decided not to converge just yet. Both of them are just a zip file, so you can rename both of them to zip files and compare them and see all your binaries and everything else. But they are different packages. So, yep. And we will have phone training in the near future. We'll probably have a free online event like the ones I announced for Windows. But we're probably a month or 2 months away from that. So, but if you watch everything that I show you for Windows, we're gonna, like, the SAML training is gonna be all about SAML, and the iOS to Windows training talks about Objective-C to C# and a lot of, SAML and a lot of things that are very usable for phones. So you'll be able to get there very quickly. On the DirectX world, when I talk about the 3 models, the 3 choices that you have for phone, on the DirectX world, DirectX is the same, so that's actually the one that we're sharing the most. That's the one that's, with regards to WinRT on between phone and Windows. DirectX is literally the same, so that's where the most of the code sharing happens. The SAML is very close, and phone does not have HTML. I talk about, I don't like the way Apple does it, where you have a web view and you kind of have a bridge. That's what you have to do on phone today. They got to work on making sure that they have a first-class HTML. It works, but it's not perfect. So, any other questions?
Something like self-row index path that you can use to have fast lists and just get the data that you want when you haven't done anything. How
Yep.
would that map to anything like
Yep. So the question is, how do you do something like set for row index, right? Because that's kind of, you're expecting a callback. And I didn't talk about items controls because that's a little bit more intricate than what I had time to explain for. But the way it works for us is this. So you're using data binding, and our data bindings have this thing called templates. So we're actually creating, very much like if you think about UI table view, they kind of give you 4 different templates by default. And then you can go in there and set row index path, and all you're doing is setting values for the templates. And what we do here is we allow you to create any template you want. And then in order to get that set for row index paths, we also have enough callbacks in the items controls where we have, for example, something called the template selector. And there you can just go in there and do the code by yourself. So there is enough callbacks in there that you can do the equivalent functionality. For the most part, you're not going to need it. You should let the data binding do its magic. And our templates are much more flexible, so you're going to get the power of that. So you'll have that functionality. But we do have the callbacks. You're not going to be missing out. So, okay, I think I'm a little over my time. If anybody has any more questions, feel free to come up to the front. I want to make sure that Bart gets settled. Oh, by the way, if you're an iOS guy, Bart Clays is talking next about the design differences between iOS and Windows, and it's a really, really great presentation. So you might want to stick around in the same room. He'll be here in the next half an hour. He's got a gorgeous-looking presentation. He's built like 50 Windows Store apps, and they're all gorgeous. If you saw the keynote where you saw Foursquare, that's something Bart did. So he's a really great designer. Stick around if you can. If you have questions, come back and talk to me here. Thank